Okay, so for 9.3, the objective is I can find the probability of compound events. And first we need to go over a definition. This definition is going to be the sample space. And the sample space is the set of possible outcomes. So one thing to be careful of is the sample space is not a number, it's a list of all the possible outcomes from a probability experiment. And we can have it as a list, but we usually do it as a tree diagram. So how you make a tree diagram is, let's do an example so we can show how to do a tree diagram. Let's say you are flipping a coin. Oops, I spelled that wrong. Flipping a coin and rolling a dice. Oh, I should say a number cube. We want this set of possible outcomes. We want this sample space. So we make a tree diagram and we think, what are our options for each event? So for the first event, for flipping a coin, we have two options. I can either have my coin land on heads, or I can have my coin land on tails. So those are my two options for flipping a coin. If my coin lands on heads, then I roll the dice. I could get a 1, I could get a 2, I could get a 3, I could get a 4, I could get a 5, or I could get a 6. If my coin lands on tails, I could get a 1, I could get a 2, I could get a 3, I could get a 4, I could get a 5, I could get a 6. So this shows me all of my possible outcomes. I'm going to use H for heads and T for tails, but I can make a list now really easily from my tree diagram of all of the possible outcomes. So I could get heads in 1, heads in 2, heads in 3, heads in 4, heads in 5, or heads in 6, or I could get tails in 1, tails in 2, tails in 3, tails in 4, tails in 5, and tails in 6. So this is the sample space. It's a list of possible outcomes, and I can see it really easily once I make my tree diagram. So let's do another tree diagram. Let's do, let's say a car can be purchased in blue, silver, red, or purple. It can also come as a convertible or hardtop. So the car color can be blue, silver, red, or purple. And it can also come as, let's just say the car type could be convertible or just a hardtop. So we need to make a tree diagram to represent the situation, and then that will give us the sample space or the set of possible outcomes. So if I have a blue car, it could be convertible or it could be a hardtop. If I have a silver car, it could be a convertible or it could be a hardtop. If I get a red car, it could be a convertible or it could be a hardtop. If I get a purple car, it could be a convertible or it could be a hardtop. So we have 8 possibilities. Our 8 possibilities are blue and convertible, blue and hardtop, silver and convertible, silver and hardtop, red and convertible, red and hardtop, purple and convertible, purple and hardtop. The only other thing we need to talk about is compound events. And compound events, so they consist of 2 or more separate events. So both of these examples we already talked about are compound events, right? This flipping a coin and rolling a number cube are 2 separate events. Picking a color and a type for the car are separate events. So when we're finding the probability of one of these, it's the same as probability we did in 9.1. So the probability of getting tails and 2 is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total options. The probability of getting heads and 4 is 1 out of 12 options. The probability of getting a 5, well, we have 2 options where we rolled the 5 out of 12 options, which simplifies to 1/6. Let's look at the second example. What's the probability of getting a blue convertible? That would be one of the options is blue and convertible out of 1, 2, 3, 4, 5, 6, 7, 8 total options. So for the question for this video, you need to find the probability of having a red hardtop. That's what you're going to submit for the answer to this video.